Hello, everybody. Welcome back to our discussion of blood flow and pressure. In this video, we are going to be talking about blood pressure. Okay, so in this section, we're basically going to be focusing on this plot right here, which shows the pressure of the blood as it moves through the systemic circulation. Okay, so what you can see on the y-axis here is the pressure in millimeters of mercury. And then on the x-axis are the different locations in the systemic circulation. There are a couple of things that I would like to point out to you about this plot. First, you can see that we start with kind of a high pressure in the arteries, and then pressure falls as we move down towards the veins. And I want to remind you, I mentioned this before quite a while ago when I introduced you to the concepts of pressure, basically. I want to remind you that this pressure drop is due to friction. So we lose energy due to friction. That leads to a pressure drop as we go through the blood vessels, okay? Another thing that I want to point out is that we have these fluctuations. I'm sure you noticed that, right? We have these fluctuations in the pressure of the blood as it moves through the systemic circulation. If we start here by looking at the left ventricle, we have these huge fluctuations that are, oh, here. Okay, we have these huge fluctuations that are due to the contraction and relaxation of the ventricles, right? So we have high pressure as the ventricles contract and low pressure as the ventricles relax. You can also see that these pressure differences are transferred to the arteries here. So we have highs and lows in our pressure in the arteries. However, you might notice that although our pressure goes pretty low, almost down to zero in the ventricles, it does not go down to zero in the arteries. Why is that? That is because the arteries act as what we call a pressure reservoir in our system. So let's take a look at the next slide to illustrate this concept. Okay, so all right, so what we're going to be looking at in this slide is what happens to the arteries as the heart contracts and relaxes, okay? So in this left panel here, you can see that our ventricle is contracting. When the ventricle contracts, we push blood out into the arteries. And since the arteries have elastic tissue in them, that blood, as it moves into the arteries, it actually stretches the walls of the arteries, okay? And as it stretches the walls of the arteries, you are conserving pressure in the walls of the arteries and in the blood, okay? When we relax our ventricle, down here, what happens is the arteries then recoil. So they snap back to their original position. And as they do so, they propel the blood further along in the systemic circulation. Okay. So we are conserving that pressure as the arteries, expand and contract. That pressure doesn't go down to zero. So that's why we have our non-zero minimum here in the arteries, okay? All right, so I've talked about how we have these ups and downs in the blood pressure in the arteries. So I just kind of want to make an extra point of that. So the blood pressure in the arteries is pulsatile. We call it pulsatile. It goes up and down. And this is what allows you to feel your pulse. Like when you take your pulse in your arteries, you're feeling that blood pressure go up and down in your arteries, okay? We have names for the highs and lows that we see in our blood pressure in our arteries, and you can already see them here on this graph. But the high is called systolic pressure, and it represents the pressure in the arteries that we have during ventricular systole, okay? And then we've got our diastolic pressure, which is the pressure during ventricular diastole. Okay. Um, I also just want to mention these are typical values for systolic and diastolic pressure. So 120 millimeters of mercury, 80 millimeters of mercury. Those are pretty typical values. I also want to mention when you get your blood pressure taken at the doctor, they give you a number, right? They say something like 120 over 80 or whatever it is, 150 over 90, right? So that first number that you get is your systolic pressure. The second number you get is your diastolic pressure, okay? I also want to mention when people talk about blood pressure, you're measuring your blood pressure, really what they're referring to is the blood pressure in your arteries. Okay, so the word blood pressure, we use the word blood pressure, but really usually that is referring to blood pressure specifically in the arteries. Okay, so we just talked about the pressure in the arteries. Now I want to talk about a couple measures that we use to quantify blood pressure in the arteries. The first of those is pulse pressure, okay? Pulse pressure is our systolic pressure minus our diastolic pressure. So I have this task for you to perform. What is the pulse pressure in this diagram? So hit pause, see if you can perform that calculation, and we'll come back and do that calculation together. Okay, so let's measure pulse pressure here. So remember that pulse pressure is systolic pressure minus diastolic pressure. Okay, our systolic pressure is 120 millimeters of mercury. Our diastolic pressure is 80 millimeters of mercury. So our pulse pressure is going to be 120 millimeters of mercury minus 80 millimeters of mercury, which is 40 millimeters of mercury.